Did you ever wonder what happens after you write your code and how do you actually get the result? I'm Aleksandra, I'm from Poland and I'm an open source developer. I work with the Guild, mainly in the GraphQL ecosystem on the open source. And I was previously leading the development of a framework, Blitz.js, and I was also working at Hasura on GraphQL. So I'm more like full stack web developer, focusing on open source. So let's talk about grammars, like what makes a language. So when you think about spoken languages like English, Polish, whatever, then they all have rules. And the thing is that if you make a mistake in, for example, English, if I say I did made breakfast, then it's not grammatically correct, but still there's a chance that someone will understand me and will get what I try to say. But with programming languages, they are more strict. If you make a mistake in a programming language, then your machine won't be able to understand you. So there are rules, and the rules are very, very strict. So as everything in programming, like for example, when you have applications that interact one with another, then you have like a bunch of specifications. And those specifications are being used by developers to be able to know how to interact with a program. And the same with languages. We have specifications. The specifications are called grammars. And grammars are a set of rules telling us, okay, so we have this word in a language. What can go after that word? And what can go after like another? How to form like sentences in a programming language. So this is what we call a grammar. This is a specification based on which the implementation of the language is created and based on which developers learn how to use the language. What makes a language? So when you write your code, for example, you declare a new variable. Like let's say if we are in the world of JavaScript, we do const a is equal 10. Then like what happens? How and let's say then you make return a. Or like print A. How does your language know what to do? So under the hood, there are multiple steps. And the first one is to categorize every single word in your code into something meaningful for the language. And for example, when this part sees the word const, it knows that it's the const keyword. Then when it sees a space or a new line, that it knows to skip it because it's not important. Then when it sees a, it knows that it's an identifier and so on. And how does the mechanisms inside of the language, how do they know what to do? It's because of the grammars. Grammar is like a specification. When you have a specification, for example, for a backend service, then you know, for example, what this backend service provides. The same with language. You know what functionalities the language provides. So, for example, you know that in order to declare new variables, you use const, or in case of JavaScript, also let or var. And those grammars make the spec of the language, and also based on that, all the underlying tools know what are the tokens, like how do I categorize const, how do I categorize 10, how do I categorize equal token, and then from there they proceed to actually evaluate your code. So firstly, your language has a specification. There's a grammar behind your language, and the grammar says what rules are there in the language based on which like the implementation of the language knows how to behave. And what is the implementation? So first we have lexical analysis, which takes every word in your language and creates a token. Then the stream of tokens is not meaningful yet. We have parser, which takes those tokens and constructs a parse tree or abstract syntax tree. It basically gives context to those tokens. For example, when it says a const keyword and then that is followed by an equal token, it knows that we're going to have a variable declaration, so it creates a node called variable declaration, for example, and then this node will have information like, okay, so what's the name of this variable? What's inside of this variable? And so on. So this is like the base of programming languages, and then how to get to the result. Well, we can go from there. Once we have the tree, we can just go through this tree once, and we can evaluate it node by node and get the result. That is called a tree walk interpreter. But if we go further, we can go to analysis step, which will pick up some additional information about, for example, parent nodes or the scopes. Like if you are inside of a functions body, what can we access from the inside of the function body? So it keeps track of that. And if we go further from there, we can go to optimization step. So for example, constant folding. Like let's say you have const a is equal, let's say 10 power 5. Like maybe we don't have to run this arithmetic operation in the runtime. Maybe we can do this in the build time and just replace it with the result. So those kind of optimizations are being done after the analysis. And from there, we can go either in the transpilers path, so transpile your code to a different language. For example, you might want to transpile TypeScript into JavaScript, or we can go into bytecode compiler, so compile your code to bytecode, which will then be interpreted by a separate tool, or we can produce an executable, which you can run on your machine and get the result. And now the nice part is the bytecode path. So once we have the bytecode, which is like very low level optimized, then we can use an interpreter which goes through it and produces the result. I really encourage you to check out my personal website. I have a bunch of articles there and all my previous conference presentations. It's aleksandra.codes. Just important note, it's Aleksandra with KS, not with X. Inside, it's like a Polish name. And I also encourage you to visit my Twitter account. It's Aleksandra Says. You can send me a DM if you have any questions about anything, and I will be happy to talk to you.
Thanks for watching the video. If you want to learn more, click on one of these. Yeah, here we go. You clicked, right? Okay.